Now let's go look at solving a system of linear equations in two variables by substitution. So the method to solve them by substitution, we first choose one of the two equations in the system and solve for one variable in terms of the other. The whole goal, hopefully, is to avoid fractions if possible. Then we substitute the result into the other equation and solve the resulting linear equation in one variable. Finally, we substitute that result back into the results of the first step to find the second variable. That's a lot of words for a process. Let's go do the process and see if that helps. Okay, here's the equation I want to pick first, and I want to solve for y. So if I have 2x minus y equals -6, get y by itself, I'm going to subtract 2x from both sides. That leaves me with -y equals -2x minus 6. Then I want to divide everything by -1. So my equation is y equals 2x plus 6. Now I want to take that and plug it into the second equation up here. Instead of writing y, I'm going to write 2x plus 6. So I have 3x plus 2 times y, which is 2x plus 6, and that equals -2. So again, instead of writing y, I wrote what y equaled from the first equation. Now I need to distribute that 2. 3x plus 4x plus 12 equals -2. If I combine like terms, 3x plus 4x is 7x, and then I want to subtract 12 from both sides. I get 7x equals -14. I'm going to scoot that 7x over just a bit. 7x equals -14. Dividing both sides by 7 results in x equals -2. Okay, now you have x. You're halfway finished. You need to go solve for y. You can plug x into that equation. You can plug it in here. Or my choice would be to plug it in there. You already know y in terms of x. So let's say y equals 2 times x, which is -2, plus 6. So -4 plus 6 is 2. So my answer would be the ordered pair, -2, 2. Let's go look at number 2. I see that I can isolate y in that top equation pretty quickly. So let's do that. If I have 5x plus y equals 4, to get y by itself, subtract 5x from both sides. That leaves me with y equals -5x plus 4. Now, in the second equation, instead of writing y, I'm going to go write -5x plus 4. So I have 2x minus 3 times, what is my y? -5x plus 4, and that equals 5. You have a linear equation in one variable. Now go solve for x. First thing I need to do is distribute 2x plus 15x. Be careful, negative times a negative is a positive. Minus 12, and that's going to equal 5. I need to add 12 to both sides. And then if I combine the like terms, 2x plus 15x, I get 17x. So 17x equals 5 plus 12 is 17. So what is x? Dividing both sides by 17 gives me x equals 1. Okay, again, we're only halfway finished. I can plug that 1 for x back into either equation. And you'll remember that this equation is the same as that. So I'm going to plug that x equals 1 right here. I get y equals negative 5 times 1. Oops, I don't want to do that in red. Let's stay in green. Y equals negative 5 times 1 plus 4. So my y would be negative 5 plus 1 is negative 1. My answer is the ordered pair 1, comma, negative 1. Remember that x goes first, then y. Last example. On this one, if I use the first equation, do you see how you can get x by itself pretty easily? So I start with x plus 2y equals negative 4. If I subtract 2y from both sides, I'm left with x equals negative 2y minus 4. Now I'm going to plug that in to the second equation for x. Instead of writing 4x, I'm going to write 4 times the quantity negative 2y minus 4. So 4 times negative 2y minus 4 plus 8y equals 6. Need to distribute the 4 out front. 4 times negative 2y is negative 8y. 4 times negative 4 is negative 16. Plus 8y equals 6. If I add 16 to both sides, and then I combine the two like terms, negative 8y plus 8y, that'll leave me with 0y equals, what's 6 plus 16? 22? Oh, wait a minute. 0 times y is just 0. Does 0 equal 22? That's not a true statement. 0 can never equal 22. So guess what? There's no solution to this system. If you were to try to go graph those two lines, they would be parallel lines with different y-intercepts. Okay, I was just kidding. That wasn't the last one. One more. Let's go solve this system by substitution. Again, I'm going to pick this top equation and isolate the x. So if x minus 3y equals 4, to get x by itself, adding 3y to both sides, I get x equals 3y plus 4. Plugging 3y plus 4 in for x, I get 2 times 3y plus 4 minus 6y equals 8. Distributing that 2, I get 6y plus 8 minus 6y equals 8. Subtracting 8 from both sides, and then combining the like terms. What is 6y minus 6y? That's 0. What is 8 minus 8? That's 0. Okay, so my variable canceled out, but I'm left with a true statement. 0 equals 0. My answer is that there are infinitely many solutions because those two lines are the same line.